All right, we're just going to jump right into this. The first one, I want us to write the equation of a circle with center 2, -3 and point 46. Okay, because this wants an equation of a circle, I have to go back and remember what the standard form or of the equation of a circle looks like. So that's going to be x minus h, quantity of x minus h squared, plus the quantity of y minus k squared equals r squared. And now in order for this to make sense, what we do is we need a number for h, we need a number for k, and a number for r. Once we have that, then we are good. Nice thing is, we were given the center, and doesn't the center represent hk? So now I'm going to plug in that center. So we're at x minus 2 quantity squared plus the quantity of y. What's y minus a -3? Positive. Y plus 3 quantity squared equals r squared. Is this good enough? Can I leave it like this? No. I need an r. I need a value for r. There's two different ways to find r. The first way is think back to geometry. If I tell you this is the center and this is a point on the circle, wasn't there a formula in geometry that told you the distance from any 2 points, the distance between any 2 points, called the distance formula? Okay.
I thought it was just going to be like, what if we do like a negative triangle, a squared plus b squared equals c squared?
Well, that's where the distance formula stemmed from, but it's sort of like a shortcut to what you're saying to do. Yeah, but very smart, Danny. Good. Oh, you know it? You remember it? Okay.
Thanks. y2 minus y1 squared. Either plus or minus x minus x2 minus x1 squared.
Close. So I'm gonna, it's x2 minus x1 squared plus y2 minus y1 squared. All right, so that's one way to find the radius. But yeah, I'm not even going to do that. What am I going to do? Yeah, exactly. We know, don't x and y. We know hk is the center. We know r is the radius. What do x, y represent?
Points.
All points that exist on the circle. Aren't they telling us 4, 6 is a point that exists on the circle? Yeah. So now I'm going to sub in 4 for x. I'm going to sub in 6 for y. And then I'll only have one unknown, which is r. So I can solve for that. So that's what I'm choosing to do. So here we're going to have 4 minus 2 squared plus 6 plus 3 squared equals r squared. So all I did was I subbed in, let's do purple, I subbed in 4 for x and I subbed in 6 for y. All right, so now we're going to have 4 plus 81 equals r squared, so 85 is equal to r squared. Do I need to square root? No, because I don't need r. What do I need? R squared. So now we just plug back in, and we are x minus h squared, x minus 2 squared, plus the quantity of y plus 3 squared equals 85. and this is the equation of the circle. All right, next one. Could you stop slurping, James?
James, what are we doing?
Slurping in class?
Is that really what we're supposed to be doing right now?
Finish the problem first.
Okay, so now I'm saying find the equation of the hyperbola. Well, we have we have three hyperbolas, but they didn't say rectangular hyperbola. So we have two different regular hyperbolas. We have the horizontal hyperbola and we have a vertical hyperbola. We have to decide, because they have different formulas, we have to decide which one this is supposed to be. I know by looking at this, by looking at the given information. Can you guys figure it out and tell me how? Okay. Good. You got it. All right. Hyperbola. Good. Hyperbola. Good. So the focus is always on the same axis as the vertices. So if you notice here, it looks like the vertices are plus minus 1, 0, and the foci are plus minus 2, 0, meaning we're going horizontal, right? We're on that x-axis, which means this is a horizontal hyperbola. All right. Let's say you couldn't really visualize this. Could you have just plotted those points and seen for yourself? Absolutely. When in doubt, just plot it. See the information you have, see what it looks like. So we know this is a horizontal hyperbola. Hey, who's going to give me the equation of the horizontal hyperbola? What's the format for us?
X minus h squared over a squared minus y squared minus k squared over b squared equals 1.
Y minus k squared over b squared equals 1. Let's talk about this, some things about this. All right. In a horizontal hyperbola, the x is positive, the y is negative. Okay. In a hyperbola, the a is always under what is positive. The a is always under what is positive. In an ellipse, so the a can change. In an ellipse, is it the same idea? Is it always over the first thing? In an ellipse, is a always under whatever's first? No. In an ellipse, a is always under wherever it's long. So if it's vertical, it will be under the y. If it's horizontal, the a will be under the x. All right, so now let's go through this. We need numbers for h, we need numbers for k, for a, and for b. So we have a lot of unknowns here. Good news is we could figure it all out. I'm going to actually do a quick sketch. They're telling us we're negative 1, 1, 2, negative 2. So our vertices are positive and negative 1. And our focus is negative 2, 0 and positive 2, 0. Now the center of our hyperbola is the midpoint between the foci. So if I'm going from negative 2 to positive 2, do we all agree that our midpoint is the origin? So our center is 0, 0. So, center of hyperbola is midpoint between the foci. So now we know the center, Therefore, center is 0, 0. So now we are at x squared over a squared minus y squared over b squared equals 1. So we got HK done with. Now, if you guys remember the transversal axis length, is represented by 2a, and this is the distance between vertices. So the distance between my vertices from -1 to +1, isn't that 2 units? So that means 2a is equal to 2. So what does a equal? 1. So now I have my a, I have h, I have k. What's the last thing I need to find? B. Any ideas on how I can find B? Good, the focal length equation. So if you all remember, let's do this here. Our focal length, which we call C, is C squared equals A squared plus B squared. Now, I don't know what my B is, but I can figure out what the focal length is. The focal length is the distance from the focus to the center, not the distance from the focus to another focus. It's from the focus to the center. So how many units is it from the focus to the center? 2 units. So our C is equal to 2. So now we have 4 is equal to our A squared, which is 1, plus B squared. So B squared is equal to 3. Do I need to root both sides? No. Now we have everything we need. X squared minus y squared over 3 equals 1.
Guide anything or like mapping the hyperbola?
So, I believe in a hyperbola, every point, if I'm thinking correctly, every point from the distance, every point on the hyperbola to the focus, its distance is a constant. To the foci, yeah, to the foci. The distance is a constant. Yes. Yeah. Okay, guys, let's keep going. All right, so this one I'm going to have us figure out an ellipse centered at 0, 0, and vertices plus minus 10, 0, and foci are plus minus 6, 0. Don't we have 2 kinds of ellipses? We have vertical ellipse and horizontal ellipse. So we have to decide, is this a horizontal or vertical ellipse? And how would we know? Layla?
It's horizontal because the vertices and foci are on the x-axis.
Good. So right now, the foci are always on the major axis. Since the vertices and the foci are both on the x-axis, that means this is going to be a horizontal ellipse. So the foci are always on the major axis. So with that said, we're going to have x minus h squared over a squared plus y minus k squared over b squared equals 1. just for fun, let's pretend this was a vertical ellipse. How would this equation change?
The b squared would be under
Good. The b squared would be under the x, and the a squared would be under the y. So basically, in an ellipse, a is always bigger. Wherever a is, that's the major axis. All right, so now I need to find H, K, A, and B. I'm going to do a quick sketch. Yes.
Wait, so in terms
Oh,
of, like,
they told us center.
wait, no,
Yeah.
like in terms of like the which equation? Let's say like we knew A and B, like if you're looking at this equation, but replace A with like 16 and B with like 9. So like what I know, it's horizontal because like the bigger number's under the x.
Yep, exactly.
Or would you look for the smaller number because like that's on a fraction form?
No, wherever a is bigger, that tells you what it's going to be. So if the a is bigger under the x, then it's horizontal. If the bigger number's under the y, then it will be vertical.
Is there any scenario where they would be the same, like for A and B, or would that just be a circle?
Yes, that would just be a circle unless I can be sneaky. And it could be like, let's say, don't write this down because it doesn't involve the problem, but let's say it was like 3 times x minus 1 over 4 plus y plus 3 over 4 equals 1. So here you might think that this is a circle, but it's not. Why is this not? Because this 3 up top, are we allowed to have this 3 up top? No, so this would end up being x minus 1 squared over 4/3. Yeah, 4/3. Okay, but yes, if that 3 wasn't there, this would just be a circle. Okay, let's go back to this problem. So nice thing is about this problem is I already have what? Our center point. We already have our center point. So we don't need to figure that out. Our center is 0, 0 because it was told to us. So we're x squared over a squared plus y squared over b squared equals 1. Now we need to find our a and our b. I'm going to do a quick sketch. Now, if you guys remember, for an ellipse, the major axis is the distance between the two vertices on the major axis. So this major axis is 2a. Well, how many units between the vertices on the major axis? It's from -10 to +10, which is 20 units. So our major axis is 2a. So here we have 2a equals 20. So a is equal to 10. Foci are always inside. Vertices are outside. Is that what you just asked? Yeah. Okay, so here we have our a is 10. So now we're x squared over 100 plus y squared over b squared equals 1. Any ideas on how we can find b squared? Patient? You got it, the focal length. So remember, c is the distance from one focus to the center, which is 6 units. So now we're going to use c squared equals a squared minus b squared. So hyperbola, it's a squared plus b squared. For ellipse, it's a squared minus b squared. So we're 36 equals 100 minus b squared. -64 equals negative b squared. So b squared equals +64. So we are x squared over 100 plus y squared over 64 equals 1. Anybody still copying this?
Yeah.
Yeah, okay. Okay, next one. I want us to find the equation of a hyperbola with vertices plus minus 2, 0, and an asymptote y equals plus minus 3 halves x. Oh, one more. And the transversal axis length is 4.
Can you ever like give us information and like tell us to find what kind of graph it is?
I give you information and I tell you to find what kind of graph it is? Yes. There's a whole section on the test, and I'm going to give you homework on it, where I'm not going to give you information. I'm going to give you equations, and I'll say what kind of what kind of graph is this equation. So based on the equation, you tell me what kind of graph it is, but I won't give you different information. It's not going to be like, I'm going to give you like, these are the vertices, these are the asymptotes, what is this? I won't do that. Did I answer your question? All right, so my eyes, I should say, are going directly here to the transversal axis, because this is pretty solid information for us, because we know the transversal axis in a hyperbola is 2a. So now this is saying 2a is equal to 4, which tells us a must be 2. Now that I know that a is 2, does that help me identify what kind of hyperbola this is right now? No, it just tells me that a is 2. It hasn't identified the hyperbola for us. So now I'm going to go at the other information they gave us. They gave us the vertices, which I think in my mind would lead me to strongly believe something, that this would be a horizontal hyperbola because it's on the x-axis. But now we need to solidify this. How are we going to solidify this? Well, we're going to solidify this because the asymptote, the equation of the asymptote right here, is plus minus 3 over 2. Well, we know the asymptotes, or the slope of the asymptotes, are either plus minus b over a or plus minus a over b. This is for horizontal, and this is vertical. So here they're telling us a, or here we figured out that a is 2. And since a is in the denominator of the slope, what does that mean? Is it b over a or a over b? B over a, which solidifies that this is what kind of hyperbola? Horizontal hyperbola. So now we're going with x minus h, the quantity of x minus h squared over a squared, minus the quantity of y minus k squared over b squared equals 1. So now I know that I'm dealing with a horizontal hyperbola. I know my a is 2. What's my b? Layla?
I had a question.
Sure.
How do you know that A was in the denominator?
Because it said the asymptote, the equation of the asymptote is plus minus 3 over 2x. And in a hyperbola, our slope of the asymptote is either plus minus b over a or plus minus a over b.
Oh, okay, I see now.
All right, so I know the a is 2. Do we know the b? Yeah, how? Yes, it's like the same hands every time. Somebody knew. How do we know the b? So yeah? Good, the numerator of the asymptote. Okay, so our b is 3. All right, so we have our A, we have our B. Now all we need to do is find our center. What will help us find the center? Yeah, we can plot the vertices and find the midpoint. So here we have -2 and +2. And the center is going to be the midpoint between the two vertices. So we're at -2, +2. Our midpoint is the origin, which is 0, 0. So here we have x squared over 4 minus y squared over 9 equals 1.
How did you know that b wasn't negative because the asymptote was like plus or minus 3?
It doesn't matter because when you take +3 or -3 and you square it, it's 9. And also we always consider b positive because b is like amount of units we're counting. So it's a distance. So we always count it positive.
And because it's a hyperbola, the a will be on the just positive, on the positive side.
Exactly. Yep. All right, next one. I'm going to throw a curveball in here. I'm going to bring us back to parabolas. Okay, the first thing we have to identify is what kind of parabola do we have? Do we have a vertical parabola? Do we have a horizontal parabola? What kind of parabola, and how will we figure it out?
Is it a sad face?
It is a sad face. How did you know that?
Is the focus like the Y in the focus?
Yeah,
Seven.
if you plot this, we're at -2, 4 for our vertex, and then our focus is -2 and 3.5, which is below it. So because it's below it, that means our parabola will be opening down. So we know this is a vertical parabola. So for a vertical parabola, is it x equals or y equals? Y equals. Y equals a times the quantity of x minus h squared plus k. We have our vertex, which is nice. So y equals a times the quantity of x plus 2 squared plus 4. Is this good enough? No, I need an A. This is going to stink a little bit. How are we going to get the A? What do we have to use? Danny?
I think the focus is like H, I don't know, like 4A over like K or something.
we have to use the equation of a focus. You got it. So it is h, and then it's going to be comma k plus 1 over 4a. So what does that tell us? K plus 1 over 4a has to equal 7 over 2. Well, don't we already know a k? What's our k? 4. So now we have 4 plus 1 over 4a equals 7 over 2. I need to solve for a. I'm bringing that 4 over, so I'm going to have 1 over 4a equals 7 over 2 minus 8 over 2. I just made a common denominator. So 1 over 4a equals negative 1 over 2. I'm going to cross multiply. Negative 4a equals positive 2. So a equals negative a half. So now our equation of this parabola is negative a half times the quantity of x plus 2 squared plus 4. One more problem. Okay. 5, 6, last one. All right, so we have an ellipse centered at 5, 3 with vertices 1, 3, 5, 6, 9, 3, 5, 0. Me personally, I would just plot these points. I would just see what we're dealing with. So our center is 5, 3. There's my center. Then we have vertices 1, 3. And I have vertices 5, 6. And 9, 3. And 5, 0. All right, so what I want to do is I want to figure out which one's my major axis, which one's my minor axis. So from the center to the left is 1, 2, 3, 4 units. And from the center up is 3 units. So you tell me, is this going to be a horizontal ellipse or a vertical ellipse? Danny? Horizontal, because we're longer in the horizontal area. So now I'm going to go with, you all tell me actually, what's the equation for a horizontal ellipse? Okay. You got it. So now our center is the point 5, 3. So I'm going to have x minus 5 squared over a squared plus y minus 3 squared over b squared equals 1. And now remember, our a is our major axis, our b is our minor axis. So my a is going to be the distance from the center to one vertice, which is 4. So here we're going to have x minus 5 squared over 16. And then my b will be the distance from my center to a vertice on the minor axis. So that's 3 units, which makes this over 9 equals 1. I'll rewrite this. Anybody confused with how I got 16 or 9?
Is that why like the focal length thing is like basically the a squared plus b squared equals c squared?
Yeah.
It's like plotting the oh, okay.
That's exactly it. All right, so we are done for today.